All right.
Yeah, thank you, Fotis, for doing that, and welcome everybody. My name is Kathleen Gregory. I'm one of the co-hosts along with Fotis, who you've seen already, and Mingfang Wu for the Data Discovery Paradigms Interest Group. And welcome to our session at the 19th plenary, which is titled Searching for Connections, Data Search, Web Search, and Literature Search. So just to give a little overview of some of the logistics today, as Fotis just said, the session is being recorded. So if that's not something that you want to be present in, please just turn off your camera and your microphone. The collaborative notes have already been shared in the chat, but here's a link to them if you would like to take note of that. You can add yourself also to the attendance list within the collaborative notes and add your email address as well as your affiliation. And if you have comments or questions, you can type them directly into the notes. And you could also use the Zoom chat. And I'd also ask you to just mute your microphones at this point, because I can hear someone busily typing away, which is great. It indicates interest, but we can also hear a keyboard. So thank you. So this is our agenda for today. I will give just a brief overview of some of the history of the group and some past work that we've done. But the main bulk of our session is going to focus on learning from each other. So we will have 4 flash presentations, very quick 12-minute presentations that you see listed here on the screen. So first we'll hear from Brigitte Matiak from GASIS, then from Tim Serber, sorry Tim for the misspelling on your name there, from the DLR, the German Aerospace Center, and then we'll hear from Mingfang Wu at the Australian Research Data Commons, and also Graham Parton at the Center for Environmental Data Analysis. And then we'll really spend the rest of the session in discussion, thinking about this topic statement, which we've come to develop over the last weeks as a group, to consider how we can enhance data discovery through connecting and integrating different resources, such as data search specifically, web search, and literature. And then we'll end by thinking about what our next steps as a group could be in terms of practical outcomes, which we can develop to support this work. So just to give a brief history of the group and to give an overview of what our focus is, we really focus on, I guess, the F in FAIR, to make data findable, particularly the third aspect of the guideline, and that metadata are registered or indexed in a searchable resource. So to kind of put that in perspective, we've developed this slide, which highlights the many different players in the data discovery landscape, which include data providers. So that would be people who are providing content to be searched and describing what metadata and data attributes users might need for searching for data. And then we also have data discovery service providers. Those are institutions, repositories, et cetera, who are determining what data to index, how those data should be ranked, and developing search interfaces for people to actually use as they work to discover data. And then, of course, we have the actual people who are looking for data themselves, be those researchers, or be those other people who are approaching this task of searching for data from their own individual perspectives, living in their own contexts, and they will have different understandings of data discovery systems, of metadata structures which are necessary to discover data online, and also what data actually are. So our objectives as a whole for this group are to provide a place for discussion where representatives from across those different stakeholder groups can come together and explore these common issues of how to improve data discovery from these different perspectives. But we also aim to be very practical, and we like to produce actionable recommendations and guidelines for the different stakeholders who are involved in data discovery, be those people who are looking for data, be they data repositories or data discovery service providers, for example. So I just want to give a brief overview of the work that we have done and how we organize our work as a group. So we began in P18 with the proposal of 4 kind of task forces, which were decided on by a vote of the group members. And we developed these 4 task forces at that time, which have yielded different outputs. So 3 outputs which came out of those task forces are listed here. The first is geared more towards people who are searching for data. So we see here data discovery as being a skill, and we provide guidelines in this quick tips article for things to consider as a person who's looking for data, kind of some best practices and tips. And that has been taken up and viewed and downloaded by many different audiences and incorporated into training materials, which you can see here from these download statistics on the slide. The second output that came out of those first set of task forces is listed here, and that focused more on use cases, where we collected 80 different use cases. 40 of them were about portal functionality. And from that study, we abstracted 9 different user requirements and developed a set of 10 recommendations for repositories to think about what functionalities to include in their services. The third outcome here is a survey of practices in search services. And here I have to look. 98 repositories participated in this survey, and the focus really was on learning more about the ranking models, which were being used by different repositories. And you can learn more here by following that link if you like. I won't spend more time on that. But you can read more also about those particular outputs on the cards that have been developed by RDA, which really are to the point and talk about what the problems were, what we were trying to solve, the impact, and who these different outputs were developed for. So then after those task forces, we started 2 new task forces on granularity and focusing on schema.org, which both have become working groups in the meantime. At P17, I believe the working group for schema.org, the outputs were discussed, and the data granularity working group was also endorsed. And then at our last meeting at P18, we conducted a survey to think about next steps for our group, which is kind of indicative of how we work as a group, by identifying common topics of interest, which we want to work on. So this is just a screen from our last survey. We identified areas for work as the first 2, which we decided to kind of combine into one topic, looking at metadata enrichment and the use of ontologies. So we combined that into a single topic for discussion, as well as continuing to focus on user studies, learning more about how users are searching for data, for example, and how we can develop recommendations based on that. So those 2 topics of discussion we've been working on since P18, so for the last 6 months or so, to come up with the agenda also for today's session, which really is focusing on combining those 2 topics into a discussion topic, which we identified here, and which we'll talk about in the last 20 minutes. We also came to the decision that we wanted to learn more from each other on these different topics, and to learn more about the studies which are being undertaken at different repositories and institutions and by different researchers. So we decided to invite 4 speakers who are representative of different institutions and the different work that's being done on the topic. So now we'll hear from these 4 invited speakers about their work in this area of data search. And then we'll again follow up with a discussion and think about where we go from here. So with that, I think we will move to Brigitta's talk. So Brigitta, I'll just click through your slides. So please just tell me when you would like me to proceed to the next slide, and I will go from there.
Yeah, thank you, Kathleen. And just go to the next slide, please. Okay, so this is something that I've been interested in for a while now. And since a lot of the user studies that we used to do would all be about, okay, the person comes to the repository, how can we give them the data? But the thing that we didn't really take into account was like what happens outside of the repository before they even get there. And I actually took a survey from Kathleen and her colleagues to produce this little graphic. And it shows that a lot of people are actually not going directly to repositories to look for data, but they go to literature. A large amount of them go to literature. A lot of people also use personal networks to find data, and web search is also a big factor. Now, what's interesting about this is that web search is actually in this diagram more important than one would think, because the connection between literature and data sets is still a little fuzzy. So in most of the publication, there's not a DOI or a direct link to the data set, but it's only a description or something like okay, we took the data from there. So basically what you have is a name. And the next thing that people then do is to type it into Google or Bing or whatever they're using, and then go from there to the data or to the repository. The same goes for personal networks. And we can actually see that in the logs. So when you look at the Google Search Console of the repository, you can see that, for example, there are phonetical typos. So apparently someone has told them the name of a certain data set, but they misspelled it because maybe the spelling of the data set was unusual. Okay, so these searches are not particularly complicated. Most of them are known item searches, so someone knows the name of a data set and they just type it in and then they go there directly, so it's nothing too fancy. But there's often a certain kind of precision. And then there's the thing of disambiguity, because there are lots of data sets that actually have very common names. We have a data set that's called family. And obviously when you put in family into a web search, our data set is not the first thing that you find. So you have to use specifiers. The other thing that we're interested in is how to find tools and resources, because they are not always linked with the data as well. And this is also something that people do to use web search for to find additional information. Next slide, please. Kathleen? Thank you. So what we did to get a bit more information about this is an observation study with 12 social scientists. We recorded their screencast and what they were saying. We would ask them, in the context of your research, you need research data. For today, you decide to start with a search for research data. And then we looked at what they were doing in their environment that was before COVID, and do a screencast, and sometimes we would even use a camera to just do what they want. And they could do anything they want. So some people picked up the phone and called someone or wrote an email or something like that. So it was really completely free. And then we also had some structured interviews afterwards, asking them both on their experience and also on their data search experience in general. All that is, of course, published in the paper. So, Kathleen, next, please. Okay, this is one of the results that we had. This is a interaction sequence diagram. Just to explain that a little bit, every box is an interaction step that we found, and we grouped those according to certain very common places that people would go. So the gray one, that's Google. So I should web search, but actually all the 12 participants, because they were from Europe, use Google, so we actually specified that. But then there's also the light blue one, which is, or the blue ones, they are all literature related, and the orange ones that are all data portal or data repository related. And then we also had a study or a project web pages where people would try to find additional information about this. There are a couple of things that I find interesting, and one of them is that blue, there's a lot of blue there, just generally speaking. There's some people who barely looked at what we would call data, but they looked at literature that would point them towards data. The other thing that you might want to check out is that only 3 participants even managed to get to a data download site. So data search apparently takes a lot of time, and a lot of people were spending a lot of time evaluating the data that they were looking for. And also one thing that you might want to, that you might not have expected, is the prevalence of these study and project websites. And this becomes even more pronounced when you look at who used them, because we had more experienced users and less experienced users, and all the more experienced users, the professors, and so on and so forth. They were using these study and project websites a lot. Okay, so just to bring home the message here, we already learned from the last slide that a lot of people, 75% of the survey, use literature. We found that 83% used literature, and in another survey that from our colleague or former colleague Tanja Friedrichs also showed that 80% used literature. So you can see literature is very, very important in the data finding process. Okay, Kathleen. Okay, so what do we learn from that? So the next thing that we did was, okay, literature is important, web search is important. What can we even do? So we did have the opportunity to make a survey among data repositories in Germany. We asked 54 of them to fill out this form, and 23 answered. So we actually are repeating that right now. So after giving people some recommendations, and we are kind of curious as to how things have changed in the last year. Again, this is all published, as you can see there. So there are a couple of things that stand out. So if you want to be findable in web search, what you absolutely do need is a sitemap. So you know what kind of pages are indexed and whatnot. So one of the things that happened actually to us was that we realized that we didn't have a sitemap, and that actually only 3% of our data sets were even Google index. So 97% of them weren't even findable, not even in theory. So that was bad, and we weren't really able to know that before we started doing some installing some tools that allowed us to produce these numbers. But what we saw among the data centers is that not using these sorts of tools is actually very, very prevalent. So a lot of them don't use sitemaps, and they also don't use SEO tools like at all. And that means that they don't really know how bad they are. I mean, this is not always a problem, because sometimes inadvertently everything's fine. But you know, as a computer scientist, I have the idea that if you don't check it, it's probably not working. So this is a little worrying. Kathleen? Okay, and this is a little bit of guidance. So what can you do? What are the experience that we have with doing something? It's actually not that complicated or expensive to do that. The most important thing that you can do is to start using monitoring tools, and doing that is really just a matter of one afternoon clicking. You don't need a computer scientist or a programmer to do this. Just doing it. and having a sitemap, debug some of the errors that you see from the Google Search Console. You might want to look at mobile usability as well, because this is also often a problem. So a lot of some of the websites we had, you couldn't look at them on a cell phone because we never actually checked it. So that was also something that we found through this. Then what we were a little surprised with is that a lot of the schema.org markup that we had actually had tiny little syntax errors, and we didn't actually know them until we started checking and debugging that. And the fifth thing that we did is that we started using the names of the data sets and put them into headers and as part of the URI. And this also made quite a bit of difference in terms of ranking, for example. But the general rule that we discovered was, if you don't check, it probably does not work. That's really what we found there. So next slide, please, Catherine. Okay. So from there, we kind of try to do something like an academic study on what keywords you should use. So what we did was we looked at all the queries that led to our system, and then compared it with the queries that led to another system within our consortium. That was completely separate from ours. They had a completely different technology. And we just wanted to know, okay, are there maybe some keywords missing that that we hadn't thought of? And it turned out that we were. And ironically, the one that we did miss was data set, right? So if you have a data set, you should probably say so on your website. And we had a little icon instead, but that's not the same thing, actually saying that it's a data set. And the reason for this is that when you have this ambiguity, specifying that and I mean, this is like an interactive thing, right? You are looking for the family data set, put in family, you don't find anything, so you add distinguishing terms, and a very important one is data set, obviously. So doing that. Other distinguishing terms are something like question, questionnaire, and this is of course social science specific, but I think this can be generalized to other data sets as well, that you don't only use terms that specify this as a data set, but also what you can do with the data set, or what are specific things, because in many cases people aren't looking for data set, they're looking, for example, for documentation data sets. So having these terms as well is also very helpful. Another thing that we found is that it's important not to just have the name very prominently, but also commonly used acronyms. And this is also because, and this is a paper that we're currently writing, is that when you look at the literature, people very often use the acronym as if it were the proper name. So that means that they will also use that in web search to find your data set. And that also goes for informal names. So acronyms are in many ways informal names, but they're also like all informal names for data sets that exist, and you should be aware of them and try to put them in your metadata. The other thing that we found is, and this was when we started looking at who's harvesting us and how can we get more prominent, is that not all harvesters take all the metadata, and so all the super relevant metadata should be in title and description, because this is pretty much the only text fields that are indexed by all the big harvesters. Okay, so next one, please. Okay, so it doesn't make a difference. I would say it does. Well, I told you before that our number of index data sets actually rose from, in the beginning it was 3.6% of the data sets, and now it's almost all of them. And I only say almost because at the very high end, you would have to manually check every single one of them. that we didn't do that, but I'm pretty confident it's pretty much everything right now. We had another system where we did these things, and it used to have like between 0 and 10 impressions. Impressions means that it was part of a web search, not necessarily a part where people clicked on it, but just it was on there. People saw it. And with just a couple of very small things, we increased the number of impressions between between 0 and 10 per day to between 800 and 2,500 per day, which I think is it's quite a difference. I'm not sure what the increase is there, but it's pretty significant. And then there was another system where we tripled the number of users in 3 years by using all these kinds of measures and so on. So this is really stuff that doesn't take too much work, but it works really well. Okay, wrap up. I think I'm running out of time anyway. What I want to bring home is that a large proportion of users do find data through web search. It is therefore a good idea to improve that visibility. And there are really simple guidelines for that. And we're just putting out a flyer, giving you some basic information as well. That'll be upcoming. I actually hope it would be here today, but apparently the graphics person has found something that wasn't quite right. So, but we're really close to publishing it. There are other things that I have not been dwelling on so much. So if from an individual perspective or an individual data set, it's also important to have be represented in literature and to be represented in word of mouth, which means conferences, for example. But again, these go through web search as well. So it doesn't, it's not as good to be very prominent in literature if then no one can find your data set through bad web search. So this is actually something you should look out for. And there's a third thing that I would go into. We are currently working on that keyword thing. So if you have a data repository and you're also interested in looking into how people find you on the web search, and you have a data set for that, it can be anonymized. We can sign stuff to make sure that you don't give away anything inadvertently or something like that. So if you have access to such data, please contact me, because I think it's very important that we try to be interdisciplinary about this. I mean, a lot of the stuff that I do is social science, which is why I work for a social science institute. But I would really like to have someone, for example, from natural science, just to compare notes on how that works with you guys. And that's my last slide. And I think the next speaker is, I don't know, Kathleen, who's the next speaker?
Tim, I think, is next. Tim,
Yes.
I'll stop sharing. And Brigitte, thanks very much for that presentation. I think there's lots of things we can talk about and take up in the discussion. So I will stop sharing my slides. Tim, I think you wanted to click through yours on your own, right?
Yes.
Okay, so I'll just stop sharing here. And Fotis, I also passed the chairing responsibility over to you as we agreed. So Tim, it's all yours to share your screen. Yeah.
Okay. Hello. Yes, thank you for joining my presentation. I'm Tim Sorber from the German Aerospace Center, DLR. Yes, today I will be talking about user adaptive searching in data portals by recommending search filters to the users. Yes, data sets take very much time and effort to collect. So for example, we at DLR, we send up planes and satellites with sensors. So to make this all the efforts worthwhile, the data sets should be easily available and findable for a large audience. And yes, current research shows that available search tools in data sets are not really sufficient, and it is still very hard to find data sets on data portals. The DLR also operates several data portals. One is EOWeb. This is a geodata portal, and there you can find Earth observation data sets. And I would say it is a quite typical data portal, so you can use several different filters like limit by space or limit by time. Yes, to limit your search results, which are displayed in a list. And we attained a set of the web server data set with log files, and we built a tool to visualize the user sessions which happened there. And it was quite interesting to see that many users did initially not do the right thing. So they chose search filters which does not lead them to the correct results. Instead, we saw multiple tries, often adding or removing the filters or adjusting the filters multiple times. Yes, and we at DLR thought, wouldn't it be nice to suggest useful search filters to the users, or even discourage the use of less useful ones in their situation. On the right, you can see our current prototype. It's a Sequential data portal software. There you can see it is suggested to the user to use a format filter. And yes, at first we wanted to know, is it even possible to do this? Are there patterns in the search filter usage? And yes, we wanted to predict what search filters will be in use next, to show that there are really useful patterns in the search filter usage. For this, we decided to use sequential rules. Why did we choose sequential rules? Sequential rules have good explainability, low computing requirements, and it allows us to also discover the data. It is not a black box like neural nets, for example. I have a short example for sequential rules. So consider two sessions, S1 and S2. And yes, this could be shopping trips of a person. So person one buys first apples, then bread and cheese in a second shopping trip, and milk in a third shopping trip. From this, we could extract a rule, R1, and a rule always has a left-hand side and a right-hand side. The left side of the arrow and the right side of the arrow. And yes, this rule is quite obvious, but when we have a second session where in the first shopping trip the customer buys yes, bread and cheese, and in the second shopping trip apples, the rule does not apply anymore. So how what is the connection between shopping trips and the search and data portals, where you could see ABC and M as filters users use in a data portal, and in the brackets are single search queries. We tried to apply the sequential rules to our data set, and the results were very bad. We did not have really much better predictions than random. So there is another implementation of sequential rules. They are called partially sorted sequential rules. You can see this in my references at the end. And there, only the left side of the rule is one set and the right-hand side of the rule is one set, which is unsorted. So the rules are much less specific and apply in more cases. And yes, we also applied this algorithm to our data set. And here you can see our implementation. So we have a training data set, which are the log files from the real world portal. And we mine sequential rules for that. When a new session comes in, we extract the pattern from that rule, from that session, sorry. And we match this pattern to the left-hand side of all the rules, find the best matching rule, and use the right-hand side from this rule to make our prediction what the next search filter would be. And yes, here on the slide, you can see our results. As a baseline, we used random and always predict the most frequent item. And yes, the sequential rule-based approach had over 60% prediction accuracy. We do not claim that this is necessarily the best way. So for example, we had also to compare it with neural nets to do that. But we can confidently say there are patterns in search filter usage. We can predict them and can help users by suggesting useful search filters. Of course, there are limitations with that. Yes, the evaluation with a test and training data set does not necessarily show how useful it is to the users, and common patterns are not necessarily good recommendations. And they can help, especially new users, but they are often not the best choice. In the future, we will do a user evaluation with our search filter prediction, and we will also want to improve the prediction algorithm. So we want to rank successful searches higher, for example. Yes, now we're coming to an end. Thank you for your attention, and yes, to the next presenter.
Thank you, Tim. That was a rather interesting presentation. Thank you for sharing this. I particularly like the modeling aspect. I think it's a good example of how algorithms and kind of machine learning can be connected in that context. And I'm looking forward to discussing this further in the discussion section after. And there are already a couple of comments on the shared goal document, and I will encourage everyone to have a look, sign in, and put their comments and questions in there as well. Without further ado, I think we can go to the next presenter, Ming Fang, on the topic of user studies on listing data discovery context. So the floor is yours.
Thank you, Fortress. And do you see my slides okay?
Yeah, fantastically.
Okay, just a second, let me move. Okay, hi everyone. Thanks for participating in this session. My name is Ming Fang Wu. I'm working for Australia Research Data Commons. So I will introduce user studies conducted at Ardc for eliciting data search context. Okay, so at Ardc, we provide a national research data catalog and discovery service. It's called Research Data Australia. At the moment, the data portal has about close to 200,000 metadata for data sets. And we index everything from title, description, and every text string in a metadata record. And for these slides, the top graph, we took a system view of data search. So it starts from user have a research needs, need to find data, then come to the system and search for data and make assessment, then decide if found any relevant data set or just exit if not satisfied. So there are many broader questions we want to understand. For example, what prompt the user search for data, what's motivation for them, and how do user approach data discovery, and where and how do users search for data, and what data attribute matters to users' data need. Probably that's more important for us. Then we can communicate with our data publishers to populate those data fields. And what criteria do users apply for assessing relevance and the usability of data sets? And how would the user reuse discovered data? So that's a broader context, but specific to our data portal, we would like to know who are the users and what do they come to search for and how they interact with our system and what's their search experience. So bear this question in mind, we have conducted 3 sub-studies since last year. The Searchlog Analysis, we explore user search behavior, and the online survey, so we get to know about users and their search content and experience, and then interview with researchers to understand a broader discovery process within their research process. So this study, 3 studies from Searchlog provide us large data set so we can do aggregated quantitative search. Then the volume data getting smaller from online survey and even smaller for interviews. We can only interview so few. So, but even small data set doesn't mean less value. Even provide more value and insight into how users search for data. So we expect that the output from this project will support the maximization of data value through falling 2 areas. First, it helps us to improve the Research Data Australia, the data discovery service, and help us to identify gaps. And we also think the output could help other data discovery surveys to improve their service as well. And also this output could help us to Ardc engagement strategies by targeting those disciplines that Research Data Australia has little coverage but needed by researchers. Okay, next I will give brief introduction of each of those studies. First, I will introduce the Searchlog Analysis. So this analysis is very specific to Research Data Australia. By the way, and the RDA on the screen, the same acronym to Research Data Alliance, but in this context means Research Data Australia. Okay, we want to know who are they, what do they search for? Okay, so as Brigitte talked about, so you can use Google Search Consoles. We use that as well, but we also use a technology stack called ELK to log any significant events on the from our portal. That will give us more rich data to analysis. So we can say, which page people viewed when they search, what is the ranking of the result clicked as such. So in this study, we took a transaction log from the whole year of 2019. After cleaning up the data, we end up have 260 search sessions. A search session is from the same IP address with no more than 30 minutes in active activity. So here is an example of how this we can use this log to do. So here we can so the first one shows the interactions, aggregate interaction from one activity to next. For example, the user may landed on a page, then did a search. The search may lead to further search, then may lead to the click on the search result, and that may lead to access, go to our provider's landing page, and etc. So the bottom half shows some user just search without doing anything. So that's indicate, we need to look at more about those queries, what to infer, what they want to search. Is that a problem? We don't have a content they search for, or ranking just not good enough, just for example. And this diagram shows we can identify the gaps. So the blue bars are those collection records along each subject headings we used to classify research data. So there are 22 top headings in total. Then blue bars is what we are having. The orange bars is the filters, subject heading filters user applied in those interaction. So we can see the user hit almost each of those subject headings. It's not necessarily the one we had more click. So basically all these clicks across all subject headings. That means we need increase our to reduce our content gaps in some area. So I couldn't present all findings from log analysis. Here are just examples. Some are very broad. Probably you can get from Google Search Console as well. For example, the population. So we have majority of users come from Australia, but about 27% of them from the rest of the world. We have some we observed short search sessions, short queries, and etc. And about 70% of search sessions involves the filters, filters about subject, filters of time range, and etc. And a majority of those interactions did involve search, but not many lead to a click. That means we have need to explore further the course. And also it appears that the query need to click. They are semantically similar to the top 3 search results. That we used a language analysis tool called the word moving distance to calculate that similarity. So and also we use some attribute like a query length, interaction length, and this semantic closeness of query to search results. We broadly classify user behavior into 6 categories. This information will help us to tailor data search or predict users' behavior, as Tim said in his presentation. That's, we from the log, we have aggregated view of what user did, but we still don't know who are they. We only know them by IP address and their behavior. So we did an online survey to get more close to understand who are they as a people and what they are looking for, and what is their search experience. So we put online survey that have 13 questions to understand this user's background, search experience, and also their experience with other tools. We see if there are any correlation. And we worried we wouldn't get much response. So we also add a short pop-up survey with just 2 questions. Who are you? Why you are here? So basically, so for the whole year, we collected about 9,000 response from a pop-up survey and 120 response for the long survey. Yeah, that's not bad. If you want to see the survey, you can follow this link here. And so here are some of our findings. So majority of those survey participants are researchers and students. So and also employers from industry and the government, and also citizens as well. And a good thing is most of them landed on our portal is for data search for data sets, and their primary purpose also for research. And they are research interest usually spawn multiple their research areas, so they probably search data out of their disciplines. And the top 4 criteria for search data, first, when they come to system, is subject relevance, able to download the data, and temporal and spatial locations. And participants had a moderate success in finding exactly data sets they are looking for. We give 5 scales for them to, from not successful to successful, we got about 3.2 out of 5. So, just above average. So much room to improve. So those 2 studies are very RDA focused. So the interview is more broad. We just go through the research process with researchers, just identify where they approach and find data. So the interview design is also, we cover all the research stage and the data life cycle. We ask researchers to record instance, in a project they're looking for data. Then we go through that journey with them to find out what they do. So so far we interviewed 24 researchers. Most of them are from social science and ecosystem science. So as Brigitte presented earlier, the study from Catherine, so we have a similar findings here, so that social network and word of mouth are the most important source for discovering, collecting data by this research we interviewed. And a peer-to-peer engagement, and also the senior researchers, guidelines from senior researchers are very important. In addition to journal papers and unpublished papers, those researchers pay attention to data papers. So data paper has gained traction. And almost all participants we interviewed, they source data from government agencies, and those have prior experience working with in government, and they are aware where to go to find this data. But without that experience, those researchers are very frustrated to find government data set from government agencies. And we also found the interaction between data curator or managers and the data researchers. In many cases, the data curator guide researchers to data source and help them to make the sense of data. Yeah, so possibly I don't have time to go through. I will escape the last slides. So in summary, from all these 3 studies, they give us a different lens to look data discovery context from different perspective. And we are still in the process to trying to summarize the findings, and more importantly, to identify what the implications for data discovery improvements. Here are some preliminary implications we sum up. First, for the data search system, we need to improve search result quality, search interface, and the result presentation. And many research expressed frustration with duplicates. They go to one website, they find this data set, go to another website, they find another similar set of data set. That's probably come from population among the repositories. And the researchers also express they want to link metadata with resources such as data papers, supplement materials, and so on. And they would like to have federated vertex search for their cross disciplines, so they can get rid of those duplicates. And for metadata quality, the coverage, the measurement, granularity variables, data dictionary, and they all are important to those participants we interviewed. And last but least, we probably shouldn't look at we should open the look at the discovery from not just a system view, but to look more broadly how we promote dataset in research environments, publish data papers, establish effective partnership between data producers, data managers, and data users. That's all from me. I would like to acknowledge my colleagues. They contribute to this study. Okay, thank you.
Thank you, Frank. That was a very interesting talk. I think we are getting a lovely picture of how this can work all together across the 3 speakers so far. There are already, again, some comments on the Google document. I'll leave them for the discussion afterwards. So I'll give the floor direct now to Graham, our last speaker for today. So Graham, the floor is yours.
Okay, thanks very much, Fotis. I'll try and whistle through this one just in case we're a bit short on time. So we've heard a lot of about user studies, kind of going into depth of logs and things like this. This is quite a different sort of presentation. It's more about kind of our lived experience at our archive in CEDA and what we've learned from listening to lots of the grumblings over the years from our user community. And I've certainly experienced that on our help desk. And I will try and click on the right screen. There we go. Right. So just quick overview of the archive itself. We cover environmental data from a range of different instruments and models and other sources as well. But just to give you an idea of how big we are, if we take an example of if a data set is like a haystack, then the CEDAR archive is like a very large barn, a nice open barn. We've got about 13 petabytes worth of storage, 8,300 data sets or so, 340 million files, and it's growing all the time. We've got 200,000 files coming in a day. Some of those are very small files for data sets. Some of them are very large files, very complex and quite a variable, different types of data as well. But it also leads to kind of one big problem is how do users find the needle in the haystack? But before we get into the users, just a quick idea of who our users are. So we've got a globally diverse community, 70% in the UK, 30% from Europe, the US, and elsewhere in the UK, around the world. We've got about 70,000 registered users over our 25 years worth of sort of being in existence. And we've got lots of unregistered users as well to reflect the different access types of our data. We've got a very wide range of skills and experiences within our community as well, and a very diverse domain backgrounds. But the question is, what's their angle? How do they come in to do their searches? So I'm going to use 3 users to represent our cases. I'm going to borrow a British sitcom, some characters from there. So we've got Jen, who's our typical sort of researcher who has great domain knowledge and uses the tools that she needs and is willing to kind of get on and do the research to overcome the barriers to get the job done. I've got Roy, who's knows a bit of tech, but it's not his native domain at all. And it sort of represents the wider community who wants to just find the path of least resistance, get in, find the data and get onto the next job. And then we've got people like Moss, who are a bit of a geek, who know how to use all the tech APIs, formats, ontologies, but they'll also come and let you know where there's holes in your systems as well. And these sort of represent our sort of data scientists. And at the end of the talk, I'll briefly mention Douglas as well, who sort of wants to find the sort of commercial impact, who could be like the stakeholders, like your funders, who want to ask other questions as well. But how would they sort of find their data? So we've got Jen, who says, basically, I want to go and search what's in the literature. We've got Roy, who just wants to kind of Google for everything because that's what he's used to doing all the time. And then we've got Moss, who says, no, surely you want to use APIs, ontologies, and PIDs. That's the way to go. And we've got to try and sort of help all of these people. So over the years, we've built many different ways into our data into the archive, using the catalog searches, direct access to the archive itself, various different portals to satisfy particular communities or particular data sets, and people find it a very confusing situation. It is crazy. People say, why does Google just take me into wherever? Because Google harvests this, and as a result, when people put in search terms, they land in our ecosystem and they get lost. So we have to sort of think about how we can help that one. And there's Jen sort of say, yeah, but what about the literature? Surely that's what you want as a researcher. So yes, we're going to try and solve this one via a triangle. And also Moss is asking, how do we keep it all up to date? And the 3 bits are kind of, we're going to look at content, we're going to look at connections and relevancy. The first one we're going to look at is content. So just to give you an idea of the sort of the scale of things, we use, and the tools we have, we've got a huge range of different types of files and volumes within our data sets, sort of displayed there on the graph. And we use Elasticsearch to get a really intimate knowledge of everything that's in the archive, all 340 million files scanned into our Elasticsearch index. It's scalable, it's fast, it copes with the massive influx of data, and we're able to kind of scan and extract information out of the files themselves as well. So that can kind of cope from the very small individual one file in a data set all the way through to huge data sets, depending on how well sort of structured they are, and some of the bizarre data sets that we get that come in as well. But there are limitations. It cannot deal with anything that's offline, that's been removed, or external content, because we can't scan them, obviously. They've got issues where we can't scan the internal metadata because the file formats are not one of our 9 main types of well-structured formats. There may not be the required metadata, and the information may not be correct as well. So I'm going to use parameter information as a sort of an example on this one. So 48% of our archive, we can actually take parameter information from. But we want to also have parameter information for everything. And as Moss points out, there is a limit on the manual metadata that we can do, in terms of the number of files or the total volume, which means we've still got a big headache. So I'm going to go up from this lower level of the archive through to the next level up, which is the catalog, and how we can augment the information which is in there, which is where people really like to come and search. And the way we've done that, we've built not only an aggregator for the information in that file-based index, which can cope with aggregating information up on a single file or many files, but on the side of it, of our catalog, we've also got a CEDA manual metadata store where we can add in additional information to augment what we get from our file-based index. And that can do things like, we can be the place of truth in our manual metadata store, or we can augment, replace, append information that we get from our aggregator. So that gives us a scalable approach to replacing the data, so the information that we get from the archive. So this is a graph showing you the range of different data sets that we have in terms of files and volume, as I said before, and the colors indicate where we are able to harvest information, the parameter information. And you can see it's quite variable, but adding in our CEDA manual metadata store means we get that global coverage as well. It really improves things. So that kind of gives us an approach to kind of scale the content that we can feed through to the catalog. We go up that level. But as Jen sort of points out, where's the connection to the papers? And Moss says, okay, well, actually, what about related data sets, the background information that he really wants to go in depth? And then we've still got Roy there saying, yeah, but that's fine inside your own services, but what about, Google? So we're going to look at connections. First of all, to answer Moss's question, we've got our catalog, which has got 19,000 odd records in it of a range of different types. The data sets are the main things they connect to the archive. All the other records, they're reusable inside our relational database to give that background information about the who, what, where, how the data were actually produced, all of which are useful bits of information when people wish to search and find relevant data. And it's all hyper-connected as well. I mean, if we add in the connections, this is a view from 2016, and there are already sort of 70,000 connections if you take the main object types and the party records as well. So people like the authors, the publishers, and so on and so forth. And we generate a lot of this content also from scripts as well. So we look at what's in the archive, we harvest what we can to then build the catalog records. So again, it's about scalability and bringing information through so make sure that people can find it. And we then make that information available to go beyond CEDA. And we do that through the various sort of XML endpoints, which can get harvested for various dedicated portals, like the data.gov.uk, for example. We've got ESA CCI portal, and a few other sort of dedicated project portals. But also with our schema.org markup, we're making sure we're being harvested by Google dataset search as well. And also we've got the RESTful API endpoints for anybody else wishing to come in and harvest information from us. And yes, Roy, you did just hear Google. Now, Jen's also asking, but what about papers? Where's that crucial link? Now, this is something we've been working on for many years at getting data citations right and to promote them to our community. And as part of that, also making sure we can mint DOIs to our data sets. Now, we do not mint DOIs for everything. Yeah, that's because we can't in some circumstances, because we are aware that some of the licensing means that some of those data may disappear from our archive in due course. Now, in answer to kind of Jen's question, there's the whole sort of how do you link papers and data sets together? And it's to kind of help us to sort of bridge that gap. Yes, there are citations which appear in papers, but they will point back to our data sets in some circumstances. But we also want to go the other way. Again, it's to be able to say, okay, we have our catalog records. How do we point back to the papers as well? So we join up that data and literature research. And Scholix is a wonderful tool which is out there, which you can go in. You can say, okay, these are my DOIs of my data sets. Can you tell me the relevant papers which are connected to them? And that's a nice sort of open, sort of free tool that's provided by OpenAir. It's a nice index with many, many millions of links in there, as you can see on the right-hand side. And it's a very simple model where you have the source object, through to the target object and the relationship, and you can really sort of explore that through their APIs. Just to show you how much this is getting embedded within the wider community, so a bit of a study that was done by Joris van Rossum from STM a couple of years ago, and he let me borrow his slide for this talk and a few others. You can see that back in 2020, there is definitely an increase right across the board in terms of the number of journals asking for data policies now, and for articles which have data availability statements, which are crucial for kind of these joins. And the journals that connect through to Scholix as well is increasing, already up to like 40% back in 2020, from a range of different publishers and 13,000 different journals. Just to show you how that sort of looks inside one of our sister data centers, because we haven't quite implemented it in our own catalog yet. They have a nice data set record there, which has got a nice DOI, and they followed through these connections through Scholix. They found 5 citations for their data set, and there they are nicely listed. And you can follow those links through to the actual articles themselves, and you will find the reference through to the data set. And also they've got links through from the publishers through to Google Scholar. So you can see the literature and paper connections starting to emerge. If you go through to data, the data search in Google as well for the same paper, they also are picking up the links through to Google Scholar, and actually they're picking up even more information as well. And I'm going to demonstrate that that's quite an interesting thing by looking at so non-DOI'd links. So this is a data set, UK Midas data, which is nice weather data from the UK. This does not have a DOI in our catalog, but we've had it scraped through the schema.org markup into Google's dataset search, and they have gone ahead and actually found papers which are actually citing it. So going through to the Google Scholar connection, just to see what they are, we're actually finding it's not just papers they're picking up, but they're also going down and they're finding references in the in master's theses as well. So Jen's saying that's perfect. That's just what she wants. So we've looked at connections, we've looked at content, but what about relevancy? Because as good as things may be, if it's not relevant to the person, it's there's no point sort of providing those connections. And yes, Google is still asking. Sorry, Roy is saying, okay, but what about his Google search? Where relevant to himself? Moss wants to kind of go deeper with the searches, and we've got Douglas popping up now saying, actually, he wants to know what's available for commercial gain. So kind of explore this one. We have actually been using a range of different Google tools. So we use the Google Search Console, which you've already heard from a number of people, and that's great for getting those insights into the schema.org markup and the issues there, but also to discover what people are putting in their search terms and where it hits inside your ecosystem. So for example, for us, one of our most popular searches actually goes to a news item, which acts as a great signpost to then data sets, which was kind of a bit unexpected. We also tag that with our Google Analytics as well, so we can actually see the various different sources that people are coming in from, whether it's direct links from other sites, or if it's Google searches, or through to social media routes. And then we can actually track people's behavior right across our ecosystem as well. And then one other thing which we do to try and address that problem of people landing in our ecosystem and being completely lost and asking questions within a particular search term, which is actually answered somewhere else, we actually use the Google Search Console to then scrape our sitemaps to then feed into a custom search tool, which we can provide at various points in our ecosystem. So when a user asks, for example, on our web processing service about a particular site, which is producing weather data, they won't get a response ordinarily, but the Google custom search says, actually go over here, you'll find your answer, and then we can provide links as well through to the data. Just to kind of go deeper to answer Moss's question, how do we then sort of make sure that the relevancy can sort of adapt to that? And one of the things we're exploring at the moment is using Stack, and this is a file level discovery tool. So not just the data set level, going right the way down, or as I've pointed out there, it's unrolling the data set hay bale for discovery. And that allows us to add in, lots of additional things like about using vocabularies, ontologies as well, the faceted search to really give it a rich experience. And if you want to know more about that, we've got links to our tech blog and also a presentation given by my colleague Rhys Evans there on YouTube. but also about the relevancy. Is about somebody may come into the archive, they may drill all the way down to the data, but if they can't use it for their purpose, then they've got a lot of wasted time. So we're trying to build in a license classification scheme that we can provide as a top level facet to say to people, what's the use that you're trying to do? Are you interested in anything that's available for commercial use, educational use, personal use, government use, and so on and so forth? And whatever weird and wonderful purposes they may want to have as well. And that's something else which we are close to kind of adding into our catalog now. We've done all the work under the hood. We're ready to kind of go with that. So that's just a very quick overview about the different search needs and how we're trying to address them within CEDA. And that'll do.
Thank you, Graham. That was an awesome presentation. I really like the personas there. I think they reflect a lot of the usual questions that you get when tackling that. All right, we are a bit of time, but not too much. It gives us a few minutes to tackle on the last point. So before I get to that, let me see if I can share my own screen now. I'll try to share both the slide and this one because I want to switch between the two of those. I'll start by saying that there are already a few comments here. Looking through them, I see that there are some interesting points being raised. So please feel free to review and comment on those things. And so the next, the last part of the session is essentially to go and see how we can combine all those things together. Essentially, there are two main topics that may be interesting discussion. So one, and both of them are looking ahead into what could be a potential task force that will be picking up the work under this industry group. So having a regular monthly call under this interest group, we've ended up with a particular topic statement that feels relevant here. And I feel that the presentations of the four speakers so far actually reinforce the point. So the topic by itself I'm highlighting here is essentially how can we enhance data discovery through the connection or integration of multiple resources, which include, for example, web search, literature search, data repository search, and ultimately what would be the corresponding best practices and recommendations that could be offered to repositories aiming for user studies. The presentation that we have had so far basically brings the whole gamut from looking at how you can increase the visibility of your data sources per se, as was described, using icons might not be the ideal scenario here. We also need to employ new technologies on identifying and identify patterns in the behavior of the users in a way that this can be reusable by a repository to enhance the experience and sort of promote the best practice that we like. And essentially identifying what are the right tools for the right job, from the user interviews to the online surveys, and of course the Searchlog analysis. Each of those has a different perspective, a different insight that gives you in this case. And ultimately, what we end up here is essentially how to put all of the things together. Finding data is in this time and era, it's really challenging for the users, as Graham said. And one solution that was promoted here is to look at this triangle of looking at the context, the connections, and the relevancy, which I really liked. So what I would like to get here is essentially two questions. One being, do you feel or do you have any major concerns or feedback on the actual topic statement? Again, this is how we envision the work moving forward and what would be the potential outcome. So looking forward in the next 6 to 12 months, and if this is actually the work that we will be aiming for, are there any thoughts or comments on what would be missing, or if it's fine, or if there are additional components that need to be under consideration. Of course, the Google documents here for everyone, so feel free to put your thoughts directly in, or put in the chat, or raise a hand. I will assume that the silence is that everyone is exhausted, or it's a tough act to follow after these talks. Graham has a hand. Yes, please.
Yeah, so I'm just going to sort of pick up on the sort of the web search and literature search aspects in particular. So, I've sort of in the presentation I was talking about how we've found many sort of connections to our data through kind of citations in the literature, but I seem to sort of pick up from the earlier presentations that that's not necessarily the case in all domains. So are there things from one domain that kind of can influence the development in other domains? So is the environmental domain particularly well developed in that regard? It's a question I don't have experience beyond our domain, so I'd be interested to hear what other people think.
Thanks, Graham. What I would say, just to get things started, I cannot answer this question directly, of course. I'm far from an expert, but what I would say is that when we start looking into this particular topic, I fully expect that every kind of a domain, there might be some variations here. So if we're looking at the actual best practice recommendations, they would essentially emerge from a particular domain and then being adapted to expand and encompass the other domains, the needs of other domains as well. And that's how I would approach that. Of course, are there any other thoughts or comments? That would be much appreciated. Leila, please go ahead.
Hi, Fotis, thank you. I have one question. When you say here aiming for user studies, does it mean similar analysis to the ones that were presented by DLR, by Ming, Fang, and by Guesses today? Kind of analyzing what the users are doing with their systems and what they are looking for, or?
That's a good point. The way I interpret the user studies here is essentially how can we enable the users to actually do what they want, which is essentially find data sets.
Okay.
If that would be, yeah, please go ahead, sorry.
Taking this into account, that what we want to learn is what the users need and how they interact with our systems. I think I posed this question in the minutes. Is why it is so rarely that we actually analyze user interaction with the system. We have been using, if you go to a commercial website, they're talking everything that you do, and they realize that you like better one thing than the other, but we don't commonly do that kind of user interaction analysis. And we have seen today that the analyses are mostly done based on logs, on static logs, something that already happened, and we don't observe the behavior of the users in real time. So I would like to know from the panelists today whether they see any use case for analyzing user behavior in real time.
Someone.
Okay. Yeah. So
please go ahead.
Oh yeah. So we actually did an observation study, and we looked them over the shoulder, and it was quite insightful. And there were a couple of things that we didn't see also about our own systems, because we usually just looked at people who did make it to our websites, and then having this whole context, it was quite insightful. But I also must say that usually what you see is kind of what you would assume to see. So if you look at the logs, it's not like we didn't find something that was like totally different when you do the observation. There were subtleties that were different, especially the importance of literature search and web search, which of course you cannot observe when you just look on the logs. And that's why it was important for us to have this context, but it's not like we didn't see that we severely misinterpreted anything. It was just that we were not aware of the whole picture, just the small part that was pertaining to our repository. So I think if there was something that was misleading about not observing people and just looking at the logs, I think it was that we were missing a large part of the ecosystem and the importance of it. But we didn't really find that we misunderstood anything that people were doing in our systems when they were doing it in our systems, if that makes any sense to you.
Graham, I think you had a hand as well.
Yeah, I think kind of the two approaches need to be complementary. You know, the internal logs and even kind of the analytics through when somebody's on your site are great for kind of the traffic and what happens when people arrive there. I think the Google Search Console is a fantastic insight into what happens before people come to you. And you know, as Brigitte was saying about kind of looking over somebody's shoulder, you know, it kind of gives you a slight approach to be able to do that at scale. Of being able to kind of look over the shoulders of seeing what people are doing on their searches inside Google land, related to kind of what your content. The other thing which I've seen but not used and would be interested in looking at as well is you can find little plugins for your sites which can show you sort of effectively like the heat maps of where people go and where they hover on your pages, so you can sort of see how they interact with what you've got and therefore the user experience. And I think this is something which is often missed out when we design sites and services to smooth the path through to discovery. We put too many barriers in place by we designing things how we understand them rather than viewing them from where people are coming into services. Now, I know that's not related to what we're trying to do is the connections necessarily, but I think it's an important aspect that, you know, when you want to look across somebody's shoulder and see what they're doing, but you want to do it at scale where you can't sit down and do it as individual studies, there are some tools out there and make use of them.
Thank you. I see there are two more hands. We are out of time, but let's, if it's possible, we can get a bit overboard. No, everyone suddenly closed their hands. All right.
For this, I just want to comment that the presentation just to give, you know, shown many ways to do this kind of user study. There are more methods we haven't presented here. That's need to the second tasks you proposed about is there any interest to write up, you know, what kind of study, user study we could account, you know, could carry out to the context of data discovery.
And I was going to say the same thing that Ming-Fang did, and also say to Leila, I wonder, one, if it's a question of resources, also at a repository level, or maybe a knowledge about what user studies are possible and feasible and what is appropriate when. So I think there's room to think about more types of user studies and what we could implement and recommend to repositories, which is where I see that second column in this table that we have in the collaborative notes. So if that's interesting for anyone to think about, if you're interested in participating in writing up guidelines for repositories about what types of user studies are maybe existent or possible, and thinking about that, and then please indicate if you're interested in that in the chart. And also indicate, and Fotis will wrap up with this probably, your interest in following up on this idea that we've been talking about during this session about thinking about how to integrate across different resources.
Thanks, Kathleen. I think I should be closing the session now. We are already 2 minutes over time. I would like to thank all the speakers for their amazing talks. I would like to thank all the participants for joining up until this late. I would like to ask a final request, if at all, for everyone that's here in the room, to go to the shared Google document. There's a takeaway message at the end. Any kind of thoughts you'd like to share as a final thoughts of the session from your side of view would be quite useful for us to have a better understanding of what might be additional insights from your side and how we can move forward from here. So I would ask everyone if you had spare a minute to put this in. I'll stop sharing now. I'd like to thank everyone again for joining. I think I can stop the recording now.